Hi everyone, it's a pleasure to meet you in this video. This is the third lesson in this series. Today what we are going to see in this video is classification of signals, how the signal can be classified, that will be discussed here. Okay, I have explained how the signal can be classified. So signal means a function of one or more independent variables which contain some information, we call it as signals. So based upon the time, our signal can be classified into two types. Based upon the time, our signal can be classified into two types. One is continuous time and another one is discrete time. Continuous time signal or otherwise called it as analog signal, and discrete time signal otherwise called it as digital signal. So what is continuous time signals? So continuous time signal means it is defined as for every value of time t, we call it as continuous time signal. Look at this diagram. This is the decaying exponential signal e to the power of minus at. So the graph drawn between t versus x of t. So decaying exponential. When t equal to 0, the signal will be here. When t equal to 1, the signal will be here. When t equal to 2, the signal is present. But in between these two sample period, there is also signal. So this is what we call it as continuous time signal. So for every value of time t, the signal will be take place here. This is called it as continuous time. Next, discrete time signal. Discrete time signal means it is defined as only at a specific or regular time instant. We call it as discrete time signal. See, look at here. This is a sampled version of this decaying exponential signals. Here the graph drawn between n ts versus x of n. So when nts equal to 0, there will be signal. When 1ts, there will be signal. When 2ts, there will be signal. But in between these two time period, there is no signal. The signal is absent here. So the signal, it will be defined only at specific or regular time instant. So our discrete time signal has value only at 0, 2s, 2ts, 3ts, etc. It is not defined over continuous time. We call it as discrete time signals. Next, we move on to classification of signals. How the signal can be classified? So here the signal can, based upon the characteristics and nature, the signal can be classified into different types. One is periodic and aperiodic signals, even and odd signals, energy and power signals, deterministic and random signals. So now first periodic and aperiodic signals. Okay, periodic means a signal is said to be periodic if it repeats at a regular interval. If it is repeated at a regular interval. Non-periodic means do not repeat at a regular interval. See, look at this diagram. So when the signal is said to be periodic, it means, see, look at this diagram. This is your graph. So this is your first signal. So this is your represented as 1t. It means the same signal, it will be repeated at next 1t. So next 1t. So this 1t. Okay. So now it will become 2t. So the same signal, it will be repeated after certain regular time period. We call it as periodic signal. The condition for periodic is x of n plus capital N, which is equal to x of n. If it satisfies this condition, we call it as periodic signal. Otherwise, it is called it as non-periodic signals. So periodic means, let us give examples, and by solving the problem, I will explain it. Okay. See this example. Determine whether they are periodic or non-periodic. If the sequence is periodic, determine its fundamental period. Look at this problem. Cos of 0.01 pi n, cos of 3 pi n, cos of n by 8 into cos of pi n by 8. So like this problem will be given. Okay, I solve the problem number 3. Okay, cos of n by 8 into cos of pi n by 8. So now you compare with the standard function. This is look like cos of omega 1n into cos of omega 12. So which omega will be used here means here if I put this omega, capital omega, it represents as capital omega means you just mention like this. This is capital omega. This is for analog frequency. Analog frequency, that is what we call as angular frequency. So this one is reference for digital frequency. Digital frequency. So omega naught. So now here discrete time signal will be here, given here. So I mentioned here omega 1n into omega 2n. So here omega 1 which is equal to 1 by 8 and omega 2 which is equal to pi by 8. Just you compare with the standard function. Okay. For omega, you know that formula for omega. Omega is angular frequency. It can be represented as 2 pi f1. So from this equation you find out the f1. So f1 which is equal to omega 1 divided by 2 pi. So now substitute the value for omega 1. So that is 1 by 8 divided by 2 pi. So which is equal to 1 over the period of 16 pi. Look at this equation. If both are integer, we call it as rational number. But here one is for numerator term is integer, but denominator term is not as an integer. So the given signal is said to be non-periodic. One part of the signal is said to be non-periodic, not entire part, only the one part of the signal is said to be non-periodic. Next you find out the second part. Second part is cos of pi n by 8 is given. Okay. So here omega 2 which is equal to pi by 8. So f2 which is equal to omega 2 by 2 pi. So substitute the value for pi omega 2, that is pi by 8. Pi by 8 in by 2 pi. So it means pi and pi should be cancelled out. So 1 by 8 divided by 2. So it means nothing but 1 by 16. Now both are integer. So the given term is said to be rational. So therefore this signal is said to be periodic. Okay. How to check the periodic signals? So now you find out the answer. One part of the signal is said to be non-periodic. The second part of the signal is said to be periodic. So the product of non-periodic and periodic is non-periodic only. If both are periodic, the given signal is said to be periodic. If any one of the signals is said to be non-periodic means, so totally we call it as said to be non-periodic signal. Now you understood about how to check the given signal is said to be period or non-periodic. Suppose if it is periodic means, how to find out the fundamental time period means, you just see this equation f1 which is equal to 1 by 16. It means f1 equal to k by n, f equal to k by n. So now this denominator n, it represents number of fundamental period. So here and compare with this equation, now k equal to 1 and n equal to 16. So it means the total time period is, fundamental time period is 16. Okay. Now you understood. So this is where you have to solve the periodic and non-periodic problems.